This question asks you how to calculate real return and throws a bunch of equations at you that involve nominal return, inflation, and real return, and there's even one that includes deflation. This is an interesting question, and we decided to cover it mainly to show you the process I would use to answer it, which I am sure you will agree is much simpler. You probably already understand this concept, but the right answer may be harder to find without the use of numbers. Here's a trainer's tip. Before you get overwhelmed by the question itself, think through some numbers in your own mind that make sense and jot them down. For example, if you earned 10% on an investment, but during the same time frame, inflation was 9%, which means prices of things went up, your purchasing power would really have only increased by 1%. Makes sense, right? Stated as a formula, if we take the nominal return of 10% and subtract 9% inflation, we get a real return of just 1%. This formula is one of the answers provided, so let's flag that as the correct answer for now. You can use these same easy numbers to test and eliminate the two other answers that involve inflation. If you plug 10%, 9%, and 1% into those equations, the math just doesn't work. For example, we can eliminate the answer real return equals nominal return plus inflation because a nominal return of 10% plus inflation of 9% would equal 19% real return, not the 1% real return we know is correct. Now, to test and eliminate the answer that involves deflation, we would have to make up some numbers that we know would make sense in a deflationary environment, which is where prices are actually going down. Let's think through that first. For example, if you earned 10% on an investment and during the same time frame deflation was 9%, which means prices of things went down, your purchasing power would actually be 19% better. You made money and things got cheaper. Makes sense, right? If we plug those numbers into the equation provided in that answer, the math just wouldn't make sense, so we can eliminate it as well. Much like how a golfer needs to think through the best way to approach a hole given his skills and weaknesses, students need to think through the best way to approach each question given their skill set. If equations intimidate you a little bit, it may help to think of a simpler scenario, perhaps with easy numbers to get your head in the right place before tackling a tricky question.